Hello from RCF. In this video, we are going to align an audio system in the crossover zone in a real situation. Before go on, I suggest to watch the part 1 of this tutorial in order to understand some concepts that are taken for granted here. Now let's place the microphone in the zone of the audience we want to align the system and take the top curve. Don't care about the frequency response in the mid and high frequency because it is not the content of this tutorial. And capture the measure of the tops. Our crossover is at 80 Hz butterworth 24 dB per octave, which is a common high-pass and low-pass filter in RCF products. You can see that in the crossover point we have 180 degrees of phase shift due to the filter, as in the previous example. Mute the tops and go with the subs. Capture the subs. You can easily see that we are not aligned. Indeed, if we unmute the tops, you can see a big cancellation due to the phase mismatch of the two signals. In fact, the phase low is going upward in this frequency range. That means that the subs are in advance compared to the tops. Start to apply delay. You can see that with 7.5 milliseconds of delay, we are in phase at 80 Hz, but the two traces have not the same slope yet. Anyway, capture the sum, unmuting the tops, and name these measures as first attempt. To make the phase trace steeper, to achieve a better alignment, we have to increase the delay of the subs, as we saw in the part 1 of this tutorial. So let's calculate the period at 80 Hz, which is 1000 milliseconds, divided by 80 Hz, that is equal at 12.5 milliseconds. Add this value. 7.5 plus 12.5 is 20 milliseconds. This is much better than before. The slope is quite good, even if at 95 it starts to get steeper than the tops. Anyway, again, unmute the tops to capture the sum. This is the second attempt. Let's compare with the first, and you can see that in this second tentative, we have a better summation in the crossover with 1 dB earned. But I would like to try to reach a better overlap in this zone. Now, the subtrace is steeper here, so we have to reduce the delay. But we remember that the first attempt with one less cycle was not good. So let's try to reduce the delay by half cycle, which is 6.25, and reverse the polarity. Now we are at 20, so 20 minus 6.25 is 13.75. Let's do it. Adjust a little bit the delay to match the trace as much as possible. Now it looks much better. Capture the subs as well as the sum of this measure. Compare the 3 attempts. You clearly see that the last one, especially after the crossover frequency, is much better than the previous 2, with almost 3 dB of SPL earned, a consistent amount of energy. The last example. In this moment, the phase traces are overlapped as good as possible. Reverse the polarity of the subs to see what does it mean to work heavily out of phase without taking care of alignment. 12 dB of cancellation in a large part of the crossover zone. It will result in an inconsistent and poorly defined sound in the low frequency. To have more details about sub-alignments, leveling and configurations, refer to our Subwoofer white papers, available for download from our website. Thank you for your attention. Bye-bye.